What if the C language had templates? This video assumes you know templates in any language. In our case, we will first review templates in C++. Second, we will see what are templates in the C language. Third, we will compare our C++ template with our C template. Templates in C++. Let's take a look at a custom data type that we created that encapsulates the functionality of a static array. Notice we created a structure of type static array, and over here we have this word called template, and then we have a couple of parameters. And so this parameter right here wants the type that the array is going to be of. Is this going to be an array of integers? Is it going to be an array of strings? Is it going to be an array of a custom data type that we have? And then the second parameter over here, which says unsigned int len, is going to be the length of the array. Also notice we have three functions here. One called set, one called at, and one called fill. Let's take a look at our main.cpp function. Notice we created a static array that is going to be of integers. We're going to have 4 integers in this static array. We initialize our static array to 1, 2, 3, 4. And notice we created our own macro function here that will print all of the values of the array onto the console, like this. And let's actually see what else we're doing. We have a v.set, so we're going to set the array at index 1 to 6. We're going to then print all the values of the array. Then we're going to do v.at to access the array named v at index 3. Then we're going to fill our array with number 100. So every index in the array is set to number 100. And then we print out all the values of the array. And this time we're going to create a different array. And this static array is going to hold cstring, which is const char pointer. And it's going to have 2 const char pointers. And the initial values is C and C++. We then set the value of S0 to dlang, which is another coding language. And then we print out all the values of the array. At the end, our console should look like this. Now let's go over a problem that our static array is helping us to resolve. Imagine having to create a static array for every single data type. For example, what if templates didn't exist? We wouldn't be able to do things during compile time like replace t with int or whatever type we pass in here. We wouldn't even be able to replace len with the number that we pass in here. So we would have to create a specific static array for each type that we want to use. So let's just say in this case we want to use a static array that is for C strings. Well, we can put C string here, C string 2, and we only want 2 C strings. Notice we have a static array of ints and our static array of C strings, but who wants to manually create a static array for every data type and every length that we are going to use? And this is the problem that templates actually solve. Templates but in C. Look at our C version of our static array. Notice that our C static array has an at, set, and fill, just like our C++ version. And surprisingly, the lines are a little less compared to this. And also, we defined a static array using a macro, and our macro takes in 4 parameters, 4 or more, since we're using variadic arguments here. Our variadic arguments is going to represent a constructor in C, so I decided to just use VARGs to help with the initialization of our array. We have a first parameter, and we just pass in the type that we want the array to be of, and then we pass in the length that we want the array to have, and then we pass in the name of the array. Let's check this out in our main.c file, and notice we can pass in our type as int, we can pass in the size of our array, we can pass in the name, and look, we have our little constructor here, just like our C++ version of the static array. We also did the same thing for our C string, and notice I got a snippet of our C++ output, and now here's our console output for our C version. And look, these outputs look exactly the same. So this means we can have templates in the C language. You just have to be a little creative, and most likely when we are dealing with templates in C, we would want to use something that goes before runtime, which is macros. Let's compare C templates with C++ templates. I have a C version of my dynamic array created, and this C version of our dynamic array is going to hold const char pointers, and these are the initial values, and these are the values that we are adding to our dynamic array. Now I want to show you why the C version is not as efficient compared to our C++ version. And that is because during preprocessor time, our macros expand, and we actually have code that looks exactly the same. For example, a lot of these lines of code in here look exactly the same. It might be hard to read, but some of these are exactly the same. Like here we're adding bro 6 to the list, and check this out. This line looks exactly the same as this, and there's a few others that look exactly the same, and our main function is full of these. So the cons to using macros is they lead to code bloat, and code bloat can cause higher compilation times. So when you're using macros, you might want to be careful of how many you use in your program. Now let's talk about our C++ version of the dynamic array, which does the same thing as our C dynamic array, but in a more efficient way. While our C++ version might have a few more lines compared to our C version, at least we are not going to be expanding our function where we copy all of this and just paste it like this, like a macro does. Instead, we are going to be calling a function and going to the place where that code is. So instead of having over 49 lines of code, which our C dynamic array costs us to have, we actually have 7 lines of code here. And these 7 lines of code is all function calls. Let's go over another con of using the macros. with our dynamic array. I'm in debug mode right now and I'm about to run the code, and I want to see what am I actually doing behind the scenes. So I click this arrow. So the con to using macros is that debugging your code for macros is hard. In order to debug this, we are going to want to expand our macro, and we want to make sure that we can actually understand what we are debugging. So we do want this to be a bit more organized. So just debugging macros takes a lot of time. So that's another con to using the macros to help us templateify our dynamic array. If you guys enjoyed this video, please let me know, and if you think I missed something in this video or have advice for me improving future videos, please let me know. Thank you so much for watching, and see you in the next one.